Okay guys, so today we will be talking about circles and ratios within those circles and pi, because circles can be proportional. So we're going to kind of explore that relationship and see how we can use proportions to help us find information about our circles. So just to review, last week I gave you guys a little bit of an introduction, but just to fully review the terms. These are the three vocabulary words that you're going to have to know about a circle. We have the radius, which has one endpoint at the center and one endpoint at any point on the circle. So it goes from the center to the edge. That is our radius. Then we have our diameter, which passes through the center, and its two endpoints both lie on the circle. So pretty much cuts the circle in half. It is a full line. It goes through the center. And then circumference, which is the distance around a circle. So it's kind of like saying perimeter, but of a circle. Okay, so it's the distance around a circle. Now, our table here shows the dimensions of 6 different circles. So we're going to use these dimensions and explore the relationship between all these 3 parts of the circle. Okay? Now, they already kind of give us the information here, so we're going to take this information and figure out these ratios and figure out what the answer will be to those. Remember that whenever we see a fraction bar, that means division. So for our first column here, we are going to be dividing the diameter by the radius. So I'm going to do the first couple with you, and then you guys can pause the video and finish out the rest on your own and check your answers. So let's see, diameter divided by the radius. So 4 divided by 2. Go ahead and write it out. 4 divided by 2. And you all have access to calculators, so make sure that you guys are using those. And you should get 2. If you do 4 divided by 2, you should get 2. So the ratio of the diameter and the radius, or diameter divided by radius, should give us 2. At least for circle A. We're going to see if we're going to get the same answer for all the circles. Now we want to figure out the circumference divided by the diameter. I'm going to go here and find the circumference, which is 12.56 divided by the diameter. So the diameter is 4. So go ahead and put that in your calculators. Don't put it in as a fraction because we have decimals here, so that's not going to be able to happen on you guys' calculator. So make sure that you're using the division symbol. We're doing 12.56 divided by 4. So 12.56 divided by 4. And that should give us 3.14. Okay? Now let's see if it's the same for this other circle. Diameter divided by radius. So 6 divided by 3. And when we do that on our calculator, we will get 2. Now that's curious. I wonder if it's going to follow a pattern here. Well, let's finish out this circle. Circumference divided by diameter. So our circumference is 18.84 divided by the diameter, which is 6. So 18.84 divided by 6. And that does give me 3.14. Okay, so go ahead and pause the video and finish out that table, and then check back here in a second. See if we get the same answers. Okay. After we have completed the table, we do see that we do get the same answer for all of them. And that's because the relationship between diameter and radius will always be the same no matter what the size of the circle. Also, the relationship between circumference and diameter will also be the same. It'll also be 3.14. And I think all of us know 3.14 as pi. So 3.14 is pi. Remember that pi actually keeps going and going and going, but when we use it in math and our calculators, we just use 3.14. So let's go ahead and finish this out. Write the ratio for any circle. So this is always going to happen no matter the size of the circle. So we know that the diameter and the radius, the relationship or the ratio is 2. And that's because the diameter is twice the radius, okay? And then the relationship between the circumference and diameter will always be 3.14 or pi. So the relationship between the distance around the circle and our diameter line will always be pi, okay? Okay, so knowing that now, let's go ahead and get our notes on our notebook. It should be the last set of notes that you glued in towards the last couple of pages. So let's go ahead and get our notes. Pause the video if you need some extra time to get your notes. And here we go. So let's look at our relationships again. Radius goes from the center to the edge of our circle. Diameter goes through the center. It goes from edge to edge. It goes through the center. And circumference is the distance around the circle. So like our perimeter, the distance around the circle. So here we go. We know that the relationship between diameter and radius was always going to give us 2. And that's because if we want to go from radius to diameter, I have to multiply by 2 every time. That's the relationship. The diameter is twice the radius. Now if I want to go the other direction, to go from diameter to radius, I divide by 2 because I have to cut it in half. I divide by 2. So that's what that ratio means. Now, in order to go from diameter to circumference, I multiply by pi. And to go from circumference to diameter, I divide by pi. So this is what this means. The ratio of the circumference and the diameter will always be pi. That's their relationship. That's their ratio. So knowing that the relationship is always going to be the same no matter the size of the circle, we know that the circles are going to be proportional, and we can use this to our advantage in order to find missing dimensions between similar circles. So this is very similar to what we did previously in finding the missing side of a triangle or a missing side of a rectangle. But now we're going to find missing information about the circle. So let's read what it says for example 1. The circumference of the larger circle, so right here, is 94 centimeters. Let's write that down. The circumference of the larger circle, that's why I'm writing it underneath it, it's 94 centimeters. Find the circumference of the smaller circle. Okay, so I don't know the circumference of the smaller circle. Okay, so let's look at the kind of information that we have here. They give us diameter and they give us circumference. So that's what we're going to use as our labels. Diameter and circumference. We're going to set up our proportions. So let's start with the first circle. The diameter of the first circle is 30. So the diameter goes on top. And they give me the circumference. Remember, we got this from the information above, so it's very important that you're reading all of the information regarding the problem. So the circumference is 94. Let's see what other information they give us. I have the diameter of the little circle, and since it's diameter, it'll go on the top. And I don't know the circumference, so let's put an X there. And now we're going to solve this like a regular proportion. We cross multiply, so we will do 94 times 15, and we will get 1,410. And we know that our last step is to divide by the leftover number. So we have to divide by 30 in order to find x. And we get 47. So the circumference of the little circle will be 47 centimeters. And that's what we're going to be doing today on our handouts. So we are using our knowledge that circles are proportional and using those proportions to find missing dimensions, okay? So feel free to pause the video as you guys all will receive the handout. Feel free to leave the notes open on your desk so that you can refer back to those, okay? Okay. So here is our guided practice. We're going to do this together as a group. Remember that you can pause and play as you need to. Remember to keep your notes out so that you can refer back to those for the vocabulary. So let's look at number 1. We're going to use these 2 circles for the first set of questions. Yes, the numbers are a little weird. That's okay. Not a big deal. This is number 4. It's all good. Okay, so let's look at the first one. What is the diameter of circle A? What is the diameter of circle A? If you forgot what diameter is, we know that diameter is the full line that goes from end to end through the center. So the diameter of circle A is 12 feet. Now what is the diameter of circle B? Let's look at circle B and let's find the diameter of circle B. And we get that it would be 8 feet. So 8 feet. Now let's find the radius of circle A. They don't really give me the radius. All the information that they give me is just the diameter. But I know that radius is halfway through, right? From the center to the edge. So let's go over here. And if they give me diameter, and if I want to go to radius, what do I have to do? I have to divide by 2. So from diameter to radius, I divide by 2. So from diameter to radius, I'm going to divide by 2. So let's take that 12 and divide it by 2. And if you do 12 divided by 2, diameter divided by 2, you will get 6 feet. So the radius is 6 feet. Now let's go ahead and look at number 4. What is the radius of circle B? So I know radius is from the center to the edge. It's the half line. So we just did it, but we can always refer back to our notes. From diameter to radius, we do the division. We want to do divided by 2 because it's half of the diameter. So I'm going to do diameter, which is 8, divided by 2. So 8 divided by 2. And that will give me 4 feet. So now it's basically going to ask us to prove that the 2 circles are proportional. We know they are. We explored that earlier on our table at the beginning of class. But let's go ahead and do this again. Are the radius and diameter of the 2 circles proportional? Well, let's see. Let's make some ratios where I will have the diameter on the top and the radius on the bottom. Now let's try the 2 circles. The diameter is 12 and the radius was 6. Okay, so 12 over 6. And if we do that on our calculators, we will get that 12 divided by 6 is 2. Now let's try circle B. We know that the diameter was 8 and the radius we found it was 4. And if we do 8 divided by 4, we will find that we have 2. So yes, because their ratio is always 2. So we know that the circles are proportional. The ratio from diameter to radius will always be 2. And it doesn't ask it here, but we also know that the ratio of circumference to diameter will always be pi, 3.14. That's how we know that the circles are proportional. Let's go to the bottom. So this is most likely what you'll have on the homework that you'll be able to work on in class. If you do not finish it, then you finish it out for homework. So the circumference of circle Q, here circle Q, look for the letter, is 21 centimeters. So let's go ahead and write that information underneath it. That way we see it right away. So we have to write a proportion to find the circumference of circle P, and then it's asking us what is the circumference. So we're going to set up the proportion here and put our answer down here. So our labels, the two things that we're comparing, let's see the information that they give us. They give me circumference, but then they also give me diameter. So the labels are going to be diameter and circumference. So remember that you can start with whichever circle you want, and you can actually flip your labels as well, as long as you keep the proportion organized. We've proven that before, that as long as it is organized, we get the same answer. So I'm just going to choose to start with circle P because it's just there first. So the diameter is 3, but I don't know what the circumference is. That's what I'm finding, the circumference of P. So I'm going to put an X there. And then the diameter of Q is 7. And the circumference is 21. So your proportion should look something like this. Now let's go ahead and see what is the circumference of circle pi. So we're going to cross multiply 3 times 21. That'll give us 63. And we need to divide by our leftover number, which is 7. And we will get 9. So the circumference, the distance around P, is going to be 9 centimeters. Okay, so keep this and your notes handy in front of you so that you can complete the homework worksheet. Have a great day.